The Sieve of Eratosthenes is a simple but powerful method invented by the ancient Greek Eratosthenes to find the prime numbers up to a certain value. We shall put it in a Python script to find the prime numbers between two given positive integers m and n. But let's see how the Sieve of Eratosthenes looks like with a simple example for the numbers up to 22. We first write the numbers from 2 to 22, then we underline 2 and we stripe all the even numbers strictly greater than 2. We stripe 4, 6, 8, 10, 16. They are not prime because they are multiples of 2 and strictly greater than 2. Then we underline 3 and we stripe the multiples of 3 that are not yet striped and that are strictly greater than 3. We stripe 9, 15, and 21. Then we underline 5, and the multiples of 5 are 10, 15, and 20. They are already striped. So we just underline 5, and we may underline also the unstriped number 7, 11, 13, 17, 19. So we have done the prime numbers up to 22 are the underlined numbers, the unstriped numbers. They are 2, 3, 5, 7, 11, 13, 17, and 19. There are 8 of them, you can count. I have edited a file called eratosthenes.py. So I begin from numpy import star in order to have the library numpy. Then we define list of prime, the function with the parameters m and n. And that function will return the list of the prime numbers between m and n. If m is less or equal than 1, then m is forced to 2, because m must be at least 2. And if n strictly less than m, then n is forced to m, because it must be at least m. Then we shall initialize an array is prime of length n plus 1. We initialize it with 1s. It will contain 1s at the positions of the prime numbers and 0s at the position of the non-prime numbers. So it is 0 for 0 and 0 for 1, because 0 and 1 are not prime numbers. The prime numbers are at least 2. And then we apply the Sieve of Eratosthenes we implement it, we switch 1 to 0 in is prime for the striped numbers. We initialize a counter to 0, count equals 0, and we make a loop for n in a range of 2 n plus 1, that is the numbers from 2 to n. If n is greater or equal than m and is prime of n is equal to 1, then we have a prime number between m and n, and we increment count. Count equals 1 plus 1. Then we make another loop for m in a range of 2 times n, starting from 2 times n up to n by steps of n. So it is only the multiples of n different from n. Then is prime of m is set to 0 because m is a composite number, a striped number. Then we fill an array primes with the prime numbers we founded. So we initialize primes with zeros of length count, and then we make a loop from m to n plus 1, and if is prime of k is equal to 1, then we put k in primes, and then we return count and primes. So we save and we run, and then we apply list of primes from 2. What are the prime numbers from 2 to 10? And how many are them? There are 4 of them. There are 2, 3, 5, 7. The prime numbers from 2 to 22. We have 8 numbers, 8 prime numbers, and we have the prime numbers that we found previously manually. The prime numbers from 180 to 200, there are 5 of them: 181, 191, 193, 197, and 199. And now the prime numbers from 1970 and 2000. There are 6 of them, and we have a list. So that's it for that video about the implementation of the Sieve of Eratosthenes with Python. The Python script can be downloaded on mathedu.academy/download.